If we then add or subtract the same amount from both sides, so even if I have it algebraically like this, x equals y, and I add 5 to both sides, if we start with a balance, we end with a balance. If I start with the balance x equals y and I take away 2 from this side, take away 2 from the other side, it's going to stay balanced. And really with equations, there's only one rule. We just have to make sure we keep it balanced. And we do that by doing what we do one side, we do the exact same to the other side. So property 1 and 2 is adding and subtracting to both sides. Property 3 and 4 is multiplying and dividing to both sides. So if I start with the balance below and I triple this side and I triple this side, so I end up with, instead of 2 boxes, I end up with now 6 boxes. Instead of 18, I end up with a total of 24 kilograms. This is tripling this side. Well, as long as I triple the other side, that's going to stay balanced. Now I've kept that physically balanced. Algebraically, it's the same thing. So if I start with 2x plus 8 kilograms, and that equals 20 kilograms. Now, as long as I do 3 groups to both sides, 6 x's, 3 groups of 8 gives me 24. And again, I can't just times one piece of that by 3. I have to triple the whole left-hand side, and I triple the whole right-hand side. That's going to remain balanced. Well, what if I divide or half each side? Well, if I take half of this, I take half of that, and I take half of that, that's going to stay balanced. So 2x plus 8 equals 20. Put that in a different color here. I start with the balance 2x plus 8 equals 20. I can take half of this side, or divide the left-hand side, divide the right-hand side. If I have 1x plus 4, yeah, I've got one box plus 4, that will balance 10 kilograms. So when you have a balance, you can multiply or divide the same amount on both sides as long as everything on the left side and everything on the right side gets multiplied or divided, it stays balanced. So starting with x equals y, well 2x must equal 2y. If I have x equals y, x divided by 3 equals y divided by 3. I can take an equation here, 2x equals 12. I can divide both sides by 2 and I end up with x equals 6. And in this case here, since there's only one variable, if we actually divide both sides by 2, we actually get the value of the variable. We actually solve for x. So 2 times 6 equals 12, yeah. And that's what we're going to end up doing later on, is we're actually going to solve equations using these properties. But for now, we're just making sure we keep it balanced. The fifth property then is a basically like for like replacement or equal replacement. Any equivalent expression can be replaced by replace another expression that's equivalent. So, for example, this expression x minus 3 will balance y. That's what it means. X minus 3 equals y. Well, if I have a y here, I can replace that y. Instead of using y, I can replace it with an x minus 3. And since y and x minus 3 are the same, and y balances this equation remains balanced, and we haven't broken any rules. And for that matter, what ends up happening is we end up with an equation we can actually solve. Here we can't actually solve this. This is a relationship here, this is a relationship here. But when we substitute that y with an x minus 3, we actually get an equation that is solvable. And again, this is what we're going to eventually get into, but the main idea here is like for like replacement keeps things balanced.